Hi, my name is Doug Kwong, and I'm going to be presenting on MERS, also known as Middle East Respiratory Syndrome for Dr. Cody's microbiology class. MERS is a relatively young disease. It first appeared around September of 2012 in Saudi Arabia. It caused a huge stir in the public health community because it greatly resembled SARS, which had a big outbreak in China 10 years prior. It had the same acute respiratory failure that caused a lot of deaths. However, it was discovered for MERS that the first incident was traced back to April of 2012, which is about 8 years after the last case of SARS, so there is very little relation epidemiologically. 3 years later, in 2015, there was a sudden outbreak traced back to an individual that traveled from the Middle East, and 30 deaths occurred around that time. So all incidents of MERS are linked to contact with people in the Middle East. So it isn't exactly the pandemic that people envisioned. However, it does have a very high mortality rate, around 36%, in comparison to SARS, 10%. So it is a very dangerous disease. So how does it look and how does it act? SARS and MERS are a type of coronavirus. And these are helically symmetrical nucleocapsids that surrounds single-stranded RNA, and they gain their names from these spike-like projections of proteins from their viral envelope, which really aid their virulence and attacking of the cell. Coronaviruses commonly cause respiratory tract infections, so they're very apt at targeting the epithelial cells and cells that line basically the area of the lungs. A key distinction that separates SARS and MERS is that SARS is a lineage B coronavirus and MERS is a lineage C coronavirus. So they do come from the same genus, beta coronavirus, but they are distinct. So how do you get it? MERS is originally thought to be a zoonotic disease from camels. Later research proved that to be a little unsure. So scientists are still questioning where the true origin of MERS has come from, but they still do suggest to stay away from possibly infected camels. So the method of obtaining MERS is very similar to SARS. It's a aerosolized disease, so you gain it from inhaling these droplets of the virus. So if an infected person sneezes or coughs into your vicinity and you inhale it, you have a risk of becoming infected. The key distinction, though, is that SARS is very, very virulent and MERS is not as virulent. You have to have very close contact with an infected person for an extended period of time. So it's a very slow spreading virus, and that's why it's very endemic to the Middle East. It hasn't really spread all across the world and kill just millions of people. Also, it highly targets people that are immunocompromised, so they are already sick with like the flu or just some type of other disease and their immune system is overtaxed, or they have pre-existing conditions like cancer, diabetes, and heart, lung, and kidney diseases. So just weak and old people that are just susceptible to many diseases, including MERS. So the symptoms of MERS are very similar to other respiratory diseases. You have difficulty breathing, you have pneumonia-like symptoms, coughing, shortness of breath. And like other viruses, when your body tries to have this inflammatory response, you get high fever, you get fatigued, you have a headache, typical of like flu-like symptoms. You also get diarrhea, and when it spreads, you get a disseminated infection, which is very, very dangerous. So when MERS-CoV spreads to certain organs, you can get liver failure, kidney failure, or even lung failure from acute respiratory distress syndrome, and you can't breathe and you just die from lack of oxygen. So MERS is a very dangerous disease, and it's very effective at targeting certain type of cells, as you will see later on. The typical life cycle of MERS-CoV is very similar to that of a virus. However, it is very specialized because of the receptor protein dipeptidopeptidase 4. Studies have shown that animals without this receptor protein are susceptible to MERS-CoV. When the spike proteins on the envelope of the virus attaches to the receptor, it triggers endocytosis and it goes through its basic replication and then assembly and packaging, and then it gets released into the cytoplasm and outside of the cell, and it can go infect other cells. So it's very typical of a virus, but it's specialized by the receptor protein. So here is why MERS is so effective at causing disease. It is very good at suppressing the antiviral responses. So interferons, it suppresses the production of them, and it sort of evades the strong inflammatory response from cytokines and chemokines. So the body doesn't really know that it's there until it's too late. It also has a suppression of special 4A protein RIG-I and MDA5 in innate antiviral response, which triggers the antiviral signaling proteins. Moreover, MERS is very adept at infecting alveolar MDMs, monocyte-derived macrophages, dendritic cells, and T lymphocytes. So basically, you can say that MERS is effective at hijacking and killing the innate and adaptive immune response. So it's very easy to spread throughout the body. Also, these MERS-CoV viruses, they can bind with these T lymphocytes and they trigger apoptosis, which is cell death, basically. And they kind of eliminate these T lymphocytes. Okay. Considering that this is so dangerous, you would want to wonder, where is it and how can I avoid it? Well, in the United States, since 2012, there have only been 2 patients tested positive for MERS-CoV. And these have direct links to Saudi Arabia. So they have people that have traveled there and they have contact with them and whatnot. So there isn't a very big risk in the United States. And of course, it's not very virulent. So there have been a small number of cases throughout the world, but it's highly concentrated around its endemic region in Saudi Arabia, and of course, the outbreak from the traveler in South Korea. But besides that, there isn't very much risk outside of the Middle East. So, what are the treatments, the vaccines? For both, there are none. So, a big problem is because it's hard to find an animal model with the DPP4 receptor protein. Only 2 animals, the rhesus macaque and the common marmoset, have this receptor protein and can get infected in like pneumonia-like symptoms. And even then, their research is very limited and not very well funded. The reason for this is because despite its high mortality rate, it's very rare in comparison to the flu or other infectious diseases. And as for treatments, once you get it, there isn't any way to have any like antiviral therapy. You just have to repress the symptoms with like painkillers, and then you can get more fluids and rest and whatnot in order to alleviate symptoms. But there's nothing you can do except to wait out the infection and for your body to cure against it. And these are my works cited page from the CDC and other sources. Thank you very much for watching.